Okay, so today we'll be talking about Ansible code and its sources and supply chain security. So the first part will be about the automation supply chain, what it is and what it usually looks like. The second aspect will be about how to secure it, and then we'll draw some conclusion out of it. So very quickly about me, I've been working in IT for the last 20 odd years. For the last 10 odds, I've been working on Ansible, and I've also written some books, and I do work for Red Hat. So some disclaimers about today's presentation. First of all, this presentation is going to be a primer. We are not going too much into security. We only have 20 minutes today, not 5 days. So this is what we get today. Everything that we are going to discuss today is open source. It's also available into the enterprise version, but also in the community version. So you can use it, whatever distribution you are using of Ansible. And also there will be a lot of links into the presentation. But the good thing is that on the last slide, I have a QR code that you can scan it, and therefore you will be able to access all the slides and click all the links without having to copy them manually. So supply chain attacks, what they are, the definition of it is that it's any kind of attack that involves targeting the sourcing, the development, and the distribution of the code itself. So effectively, we are not targeting the system, but we are targeting the code that will then end up into the system. So why should we care about supply chain security in the first place? And the reason is that it can have devastating impacts on organization, because if you are attacking one specific system, you might get ownership of that system. But if you are attacking the code, then you will get ownership of wherever that code will land, which also means that it's also very hard to detect this kind of attack because of the fact that everything seems normal except for the fact that someone actually changed your code mid-flight. Also, it's very hard to defend against them because we know how to defend the system. We have done it for the last 20 odd years, or way more than that actually. So it's very easy, it's very well understood. The supply chain part is not that well understood at the moment. Also, if you are shipping your code to someone else, that someone else can also be compromised if your code gets compromised. So the blast radius is way higher. And also the fact that lately, in the last few years, we have seen more and more supply chain attacks happening. Which means that obviously we need to be even more aware today and more prepared today. So why should we as automation administrator or automation developers care about supply chain attacks at all? First of all, we need to remember the fact that usually automation code and Ansible code more specifically tends to run as root on our systems, which means that if someone compromises that code, they will compromise the systems very, very quickly. The second aspect is that usually supply chains for Ansible code are not very secure, but even more, usually they are not very well mapped as well. So a lot of times I speak with people in companies and everyone is like, oh yeah, our source code comes from here, and actually it's not true. If you map out the whole source, you will find out that actually it's way more complex than how they describe it. So automation supply chain, initially this is how it looks like. A normal person that runs automation code from their laptop to manage some nodes, fairly straightforward. We don't really have a supply chain issue here because there is not a supply chain. And then usually what happens is that we start to have a few more people. Maybe they put it, the code in Git, and then there is still one person that does the deployment. And then as soon as that person needs to go on vacation, then you start to have two people doing the deployments. So usually what happens here is that you put a piece of software there that can be AWX or Ansible Automation Controller. They are very similar, which basically does the deployment itself. And then usually you discover that you do have some collections that you are importing from third parties, usually from outside your organization. And the problem with this is that a lot of times then there is no control on those third parties. So the solution for that is to put an automation hub, either private automation hub or the Galaxy NG one, where someone actually controls the source that comes there. And hopefully you also have a CI after Git, as well as you are managing your execution environment somehow with someone that builds them, and then they get uploaded to the private automation hub or Galaxy. Now, the problem though with this is that even though now it's sensible because we are checking all the inputs, there is no way to guarantee that what that green developer wrote actually is the thing that comes here, because someone could put themselves into the chain and attack our code and change our code. So what can we do about this? So the first step is sign Git commits. It's very easy to do it, and there is also a link here, and also you can easily validate Git commits to validate that they are exactly the one that you were looking for. And if you do this, you can secure basically this part in this green box, because you have the assurance that whatever got committed is actually what you are getting into the CI if you are doing the validation in the CI phase. The second thing that you can do is sign Ansible projects, and also obviously validate them. And you can validate them either manually or into the controller itself. So in our case, obviously, we are going to do it into the controller since we have a controller there. So we can secure this part of the chain. And even more, we can also ensure that whatever code arrives to the controller actually passes through the CI, which is very important so that no one skipped the step. So we can also put signature on Ansible collections, and this can be done in multiple ways, either manually or automatically on Galaxy NG. And also very interesting, the fact that you can also import a signature on Galaxy NG that arrives from another source. So you can create a chain of trust. And also you can validate them on AWX as well as manually. So if we do those steps, what we get is we secure the collections going here as well as the collections that get imported into the execution environments. Now, it's also important that the execution environment themselves get signed, because if we imported the certifications, the certified collections there, and then we are not validating that we are re-importing the right execution environment, then we might also have an issue there. So the way to do it is, since the execution environments are standard containers, so Docker containers, Podman containers, whatever you want to call them, we can use standard tooling for containers to do that step as well. And you can have more details there. And also, to do the validation is exactly the same. We can use the Podman or Docker policy, where basically we instruct the node only to execute containers that actually have been signed by a certain signature. So by doing this, we can also warrant the other way around for the execution environments, so that basically we know that only execution environments that have been signed properly are actually being processed. So as you can see, now the picture is very different from before, because we now have the assurance that the code that our developer commit arrives to the CI and is exactly the same one on the controller. We have the assurance that those collections that person validated are the one that arrive into the automation hub, also the one that land into execution environments, and the one that land into controllers. And lastly, we have the assurance that whatever got created by that person into the execution environment is exactly what we are going to run. So as you can see, we have ensured that no attackers can hit in between the processes. Now, obviously, as you can see, all the humans are outside the steps, and the reason for that is that obviously you have to trust your people. If you don't trust your people, this approach does not solve that specific issue. It does solve the issue of, are we sure that the code they wrote is exactly the one that we are getting? But then obviously, if you don't trust the humans or some of them, you will need to add additional steps, such as peer review or other kind of code validation beforehand. But this allows us to ensure that whatever they created is arriving into production as is. Now, some conclusion on this. First of all, the fact that automation is a very interesting target for supply chain attacks because, as we mentioned at the very beginning, it gets run at a very high level of privilege, usually as root. The second aspect is that usually supply chains tend to be very long and complex because those collections usually require other stuff that requires other stuff and so on and so forth. And also the fact that it is critical to map your supply chain, automation supply chain. If you don't know exactly how your supply chain works, you can never be able to actually secure it. And also, there are many tools that can help you secure the supply chain. As we have seen, there are many tools that are Ansible specific, but even more tools that are not Ansible specific, but simply we can leverage because in the end, Ansible files are just files. So I think we have. Yep, okay, thanks. And also there is the QR code that I promised you for the slides so that effectively you can get the slides. Hopefully you are able to read it.
Est-ce qu'il y a des questions?
Hi, one question. So my question is, do you think the security risks on the supply side, the dependency trees in open source, do you think that risk is increasing? I know there's been a few publicized examples where, for example, developers, contributors have placed backdoors into code, and luckily it was caught. Is this something that you're starting to see more of in your community?
Okay, so the question is about, do I think that there is more attacks on supply chain kind of attacks into the open source projects? I don't think there are more. I think that now there is more awareness of them, and therefore more are caught or end up in the news, those kind of things. But I think that since the very beginning of open source, we had bad actors. Obviously, as if there is a small project that is used by only 3 people, it's not very interesting. But big projects, such as the Linux kernel itself and others, have had their own issues about supply chain security, even 10, 15 years ago. Now, a lot of times those are caught even before they get merged, so it's not a problem. Sometimes they are caught after, but I think the real difference from the past to today is that today we are talking about them, and we are more aware of these kind of issues, so we are also looking more to find them.
Merci.
Thank you.